Hello everyone and welcome to my latest Rust Quickie. Over my previous Rust Quickies I gave you a general introduction to the Rust programming language so that you have now a feeling how you can work with Rust. And now with the upcoming Rust Quickies I want to move more into the details of Rust itself, how Rust differs from other programming languages like C, C++, C Sharp, and so on. And today I want to start by talking about how Rust deals with the so-called stack. If you want to have a general introduction to the stack, which is more or less a data structure, you can check out that Wikipedia link, because I'm just assuming that you have a basic understanding what the stack is. So let's switch over to Visual Studio Code and let's see how Rust works with the stack. Today is the first time that we look into some assembly code that the Rust compiler generates for us. As a prerequisite, I have installed here an extension called cargo show awesome, which you can just install with a simple cargo install command, and that extension is able to show you the generated assembly code from our Rust code. I have defined here a new function called work with the stack, and I'm using here the macro inline never, so that the Rust compiler never ever inlines that function for you on the assembly level. And we can now use that extension to show the assembly code that the Rust compiler generates for us. I'm using here the cargo awesome command. The awesome command comes now from that extension. I'm passing here the module name hello world, and I'm passing in the name of the function work with the stack. With the option Rust, the output also shows you which assembly statements are belonging to which Rust statements, and the simplify option just simplifies the output so that you can read it and it's just more convenient. So let's run that. Let's go up to the beginning of our assembly code, and as you can see, we have defined here a function. In the first step for the function we need a so-called stack frame, and Rust allocates here a new stack frame with those few assembly instructions, and as you can see, Rust reserves here 128 bytes on the Rust. In the next step, I'm defining here a local variable. Local variables are always stored on the stack. When you have watched all my previous Rust quickies, you already know about vectors, about arrays, about slices, about other primitive data types, and all those things, all those data types are always stored on the stack in Rust. So this is very, very important. By now, we have never ever touched the heap. We have just worked with the stack because all those data types we have used so far, they are always stored and allocated on the stack. So as you can see, we reserve 128 bytes on the stack, and then we define the variable I and we assign the value of 42 to it. And as you can see, on the assembly level, we just move the value of 42 to the corresponding location on our current stack frame. When we go down a little bit, you can see at some point in time we are calling the print method, print function, which is called internally by the print line marker, and in the next step we store the variable j on our stack, which has a floating point value of 3.14. As you can see, that value is again moved into the corresponding location on our stack frame. Few lines down, we have again the call to our print macro, and then we have here the value my string, which is stored in the read-only section of our program, and that one is also moved into the corresponding place in our stack frame. And when you go down, you can see again we have the call to the print function, and this is also here very interesting. I've defined here a mutable variable x. I'm assigning the value of 10 to that variable, and then we are incrementing that variable by 1, means our final value is 11. And as you can see, that increment is nowhere in our assembly code, because the Rust compiler just knows, based on the analysis of that code, hey, the final value of x is 11, so we just immediately assign that value of 11 to the local variable x, and the local variable x is again stored somewhere on our current stack frame. So this is also very important. That is a performance optimization which is done internally by the Rust compiler. So this is very important here. To be more precise, that performance optimization is not really done by the Rust compiler itself. The Rust compiler uses internally the so-called LLVM compiler infrastructure, which you can see here. And that compiler infrastructure contains a so-called front end and a so-called back end. The front end is part of the Rust compiler, means the Rust compiler generates a so-called intermediate representation of our Rust code. That intermediate representation is handed over to that compiler infrastructure, and the backend just generates the final assembly code for you. So that assembly optimization that we have seen with the incrementation of that variable is just done by the LLVM backend. So it's not really done by the Rust compiler. So this is also very important to know, that the Rust compiler just uses here also other tools in the background to be able to generate you the necessary assembly code. And we can even look at that intermediate representation. Let's have a look on that one. As you can see, I have here another call to the cargo awesome command, and this time I'm also handing in the option LLVM, and that parameter just returns you the intermediate representation that is handed over to the LLVM backend. So let's have a look on that one. And as you can see, this is just the code, the intermediate representation of our function work with the stack, which is handed over to the backend of the LLVM compiler infrastructure, and that backend finally generates you the assembly code that I have shown you previously. Maybe I will also make here some Rust quickies to get a better understanding what all those things are meaning here. So also very interesting to see how Rust interacts here with the LLVM compiler infrastructure. So today we have talked about the stack. Very important to know, all local variables that you're defining in your Rust program are always stored on the stack, including arrays, vectors, slices, and so on. And by now we have never ever touched the heap so far. So thanks for watching today's Rust Quickie. I hope that you have learned a lot today, and I'm already looking forward to welcome you next week again, where we will talk about the heap in Rust. So stay tuned. Thank you.